For millennia, humanity has cast its gaze upward, wondering about the stars. We've wondered what mysteries lie beyond our world, what untold riches could be waiting for us, and what new frontiers we could one day conquer. Ancient cultures viewed the heavens with awe and reverence, shaping their civilizations around celestial bodies. And yet, in this modern era, we stand on the precipice of something truly transformative, not just as dreamers, but as explorers and innovators. Now, that dream of celestial riches is moving closer to reality. A revolution is unfolding, one that could redefine how we think about wealth, resources, and the future of humanity. Asteroid mining is the next great frontier, offering the promise of unimaginable riches, untapped potential, and new opportunities for both the Earth and the cosmos. Across our solar system, orbiting silently in the void, lie countless asteroids, each holding the building blocks of not just the solar system, but also the very future of human civilization. These space rocks contain precious metals, rare minerals, and water, essential resources that could sustain life on Mars, fuel spacecraft traveling to distant stars, and provide critical materials for industries that Earth cannot yet imagine. This new gold rush is not for the faint of heart. It's a race for resources in the infinite cosmos. And as we move forward, the question isn't just whether we can mine asteroids, but whether we are ready to reshape our future on a cosmic scale. Imagine asteroids as treasure chests floating in space, carrying more wealth than many of us could ever fathom. These space rocks contain resources that are in limited supply on Earth. Asteroids are known to be rich in metals like platinum, gold, silver, and iron. And as the demand for rare earth elements skyrockets, materials crucial for the tech industry, renewable energy, and electric vehicles, the importance of asteroids as a resource becomes undeniable. But these riches are just part of the story. Asteroids are not just about what they hold, they're about what they could unlock. Consider the importance of water. Water is not just life-sustaining on Earth. It is essential for the future of space travel. In the void of space, water could be extracted and converted into rocket fuel, facilitating travel to Mars, the Moon, and beyond. The ability to extract hydrogen and oxygen from these asteroids could allow us to create a sustainable fuel supply in space, minimizing the need to launch heavy cargo from Earth. Think about it. These asteroids are like cosmic gas stations in space, fueling a future of interplanetary exploration and helping to establish permanent colonies beyond Earth's orbit. Asteroid mining, while breathtaking in its potential, is a feat of immense complexity. To start, we must learn to reach these space rocks, objects that can be anywhere between 100 meters and several kilometers in diameter, scattered across the vastness of the solar system. Some of these asteroids pass near Earth, making them within reach of current technology. However, getting to them is no small task. Spacecraft, like NASA's OSIRIS-RX or Japan's Hayabusa 2, have already demonstrated that we can explore asteroids up close, take samples, analyze them, and bring a small portion back to Earth. But the true challenge lies in mining these asteroids on a large scale. We must develop autonomous mining robots, machines capable of extracting precious metals and water without human intervention. These robots will need to work under extreme conditions, microgravity, harsh temperatures, and the vacuum of space, all while performing delicate operations like drilling into an asteroid's surface and collecting raw materials. We may even turn to innovative technologies like laser ablation, using powerful lasers to heat and vaporize materials for collection, or magnetic fields to pull metallic resources from the asteroid. The future of asteroid mining could rely heavily on automation and robotics, with machines performing tasks too risky for human hands. At this point, many might ask, why go through all the effort? Is it worth the costs? The answer, it turns out, is that the economics of asteroid mining may be far more favorable than one might initially think. Currently, the cost of launching spacecraft and sending humans to space is undeniably high. But the ongoing advancements in spaceflight technology, particularly the rise of reusable rockets from companies like SpaceX, are already driving the costs of space travel down. But what about the potential rewards? Some asteroids contain enough metals to make them worth trillions of dollars. Take 16 Psyche, a massive asteroid believed to be made largely of metal. Scientists estimate it could hold enough iron, nickel, and platinum to dwarf the global economy. This is not just about striking gold. This is about unlocking a new era of economic possibility. With the rare metals found in asteroids, we could bring down the cost of renewable energy technology, fuel the demand for electric vehicles, and even revolutionize medicine, where rare metals are used in medical equipment. Asteroid mining could become a driving force not just for space exploration, but for improving life on Earth. Moreover, as space technology improves, the cost of mining these celestial bodies will continue to decline, opening the door to even more opportunities for industry, commerce, and scientific progress. While asteroid mining may seem like a venture aimed at the stars, its consequences could be deeply felt on Earth. We face a growing crisis here on our home planet. Natural resources are becoming increasingly scarce, and environmental degradation is accelerating. Mining on Earth is a leading cause of habitat destruction, pollution, and exploitation. Asteroid mining offers a tantalizing alternative, a way to access precious resources without the destructive impact on Earth's ecosystems. Take platinum, a metal in high demand for everything from smartphones to catalysts in clean energy technology. Right now, platinum is rare on Earth, and its extraction can be harmful to the environment. By mining asteroids, we can access a nearly limitless supply of platinum without the negative environmental consequences. Moreover, asteroid mining offers the opportunity to develop a new space-based infrastructure, fueling stations, manufacturing facilities, and habitats, without relying on Earth to provide everything. This opens the door to a future where we construct ships and space stations in space, where humanity thrives beyond Earth's atmosphere, and where we establish colonies on the Moon, Mars, and beyond. Yet, the prospect of mining asteroids raises difficult questions: ethical, legal, and environmental. Who owns the asteroids? Do private companies have the right to claim celestial bodies? Or is this a shared resource for all of humanity? The answers to these questions will require global cooperation and the establishment of international regulations. The environmental impact of asteroid mining, while minimal on Earth, must also be considered in space. Mining operations could disrupt the trajectories of asteroids, generating space debris or creating risks for other spacecraft. Responsible practices will be crucial to prevent unintended consequences that could harm space missions and infrastructure in the future. As we look to the future, asteroid mining represents a bold leap forward for humanity. While the technology is still in its infancy, the potential for this industry is limitless. In the next few decades, we may see asteroid mining become a reality, driven by advances in robotics, space technology, and a global commitment to space exploration. The possibilities are staggering, not just for industry, but for the very survival and expansion of humanity. As we push the boundaries of space exploration, we may find that the riches of the universe are closer than we ever imagined. These space rocks aren't just asteroids. They are the keys to our future, to a new era of human potential, and to a prosperous future beyond Earth.